Did you know that you can control the boiling point of the water? Let's say you want to make the boiling point go up by half a degree. So instead of it boiling at 100 degrees Celsius, it will boil at 100.5 degrees Celsius. All you have to do is put in some salt or sugar or any solute in there. But you have to know how much you put in. So the more you put in, the bigger the effect. So if you want a half a degree, you want to put 1 mole of your solute for every 1 kilogram of water. Okay, this unit, 1 mole for every 1 kilogram, is called 1 molal. M-O-L-A-L-I-T-Y, molality. So in this calculation, we will be using the unit molality. Okay, so the boiling point will go up with every 1 molal of solution. Specifically for water, the boiling point will go up by every half a degree, 0.5 degrees Celsius, for every 1 molal solution. For example, if you want your boiling point to be 1 degree Celsius, all you have to do is add 2 moles. If you want to make it go up to 101, because that's 2 of these, you're going to need 2 moles in here. You got to double it. Okay. Now this 0.5, you get more sig figs. It's actually 0.512. Okay. This number 0.512 for every 1 molal is called the boiling point constant, or the symbol is Kb. If it's water, it's 0.512, but if you have a different liquid, let's say alcohol, it'll have a different Kb. So for now, let's just focus on water. Okay, there's a formula for it, which is this, but it's pretty simple actually. So if you have, for example, before using the formula, let me show you how it makes sense, okay? So if your water will go up 0.512 degrees C for every molal, right? If you have 2 molals of water, let's say you're going to double the effect. So it'll go up by 1 degree. Now, if you have NaCl, you know that it will have 2 pieces, Na plus and Cl minus. For every 1 molal of this, you're going to get 1 of these and 1 of these. You're going to double the effect again, 2. So now your boiling point will go up half a degree times 2, that's 1, and times 2 again, that's 2. It'll go up by 2 degrees. So 2.0 degrees Celsius. Okay, so we have a formula for it, and it's like this. Okay, the delta T is the change in your boiling point temperature, which in this case will be degrees Celsius. The blue right here is the boiling point constant. The M is the molality, and the I is the number of pieces. Okay, the I in the book, they call it the Van't Hoff factor. And the Van't Hoff factor is pretty much just a number of pieces. For example, NaCl is 2, and so on. And Na3PO4 is 3. Sugar, a covalent compound, is 1. That's the Van't Hoff factor. Let's try some more problems. Pretty simple. It says, what is the boiling point of 2? Oh, by the way, let me just label this. The delta T, they have a name for it. They call it boiling point elevation. So it's how much your boiling point goes up by. Okay, so here's another problem. What is the boiling point of 2 molal solution of sugar? So your formula is delta T is equal to Kb Mi. Okay, so Kb is 0.512 degrees C per molal. That says you have 2 molals. In future problems, maybe they won't give you the molal. You solve for it. You just plug it in there. And the I for sugar is, do you know? Well, it's only one piece, right? Because it's a non-metal covalent compound. It will not split, so you only have one. So you only have the effect once. So it would be, if you multiply these, you get 1.0 degrees Celsius. Okay, so a couple terminologies here. 1.0 is called the boiling point elevation. Is equal 1.0 degrees Celsius. But if I ask you what is the new boiling point, you're going to say it's 100. It used to be 100 and it goes up by 1, so it's now 101.0 degrees Celsius. So be careful what they're asking. If they ask for boiling point elevation, you say 1. If they say the new boiling point, you say 101. Okay, pause the video and try these 2 problems. So I did this one right here. 0.512 is the boiling point constant. Molality is 2. It says right there. Oh, don't forget the unit. And you have NaCl has 2 pieces, so I put 2. So it'll be 2.0 degrees Celsius. That is called the boiling point elevation, 2.0. The new boiling point will be 102.0. Okay, so here's another problem. I want my water to boil at 105. Oh, it normally boils at 100, so the change in boiling point is 5.0. That is my boiling point elevation. Equals. What is the molality? So that means I'm solving for M. So Kb would be 0.512 degrees C over M. Don't forget those units as well. M is unknown, so I'm going to put X. And this is 1 piece, so I put a 1. Okay? What is the molality? So I'm solving for X. X is equal to 9.8 molal. Okay? If I am boiling 1 kilogram of water, how many grams of sugar should I add? So I'm asking for the grams of sugar now. So I'm going to write the formula. Molality is equal to moles over kilogram. So this is my formula. I am using 1 kilogram of water. They have to tell you how much water, obviously. How many grams? Well, if I can solve for moles, I can find grams. So finding moles, you multiply these two. I'm going to get 9.8 moles of C6H12O6. I'm going to change that to grams. 1 mole is, after adding the 6 carbons, 12 H's and 6 O's, I got 180.16 grams equals to 1,760 grams of sugar. Okay, obviously you have to be, this is just on paper, but you have to be smart about this. The sugar is not, this much sugar is not going to dissolve in this much water. That's 1,000 grams of water. So therefore, I don't think you should use sugar if you want your water to boil at 105 degrees Celsius. What should you use? Perhaps you should use a salt, maybe Na3PO4. So what happens there? You have 4 pieces, right? From this previous discussion right here, 4 pieces. So then maybe this will increase, the 4 will increase, your molality will be lower, therefore you have less grams. Okay? You can also calculate the freezing point depression the same way as you did the boiling point elevation, but this number 0.512, or the constant, is different. Okay? This is now called the freezing point constant. Okay, the freezing point constant is different. It is almost 2 degrees actually. It's 1.86 degrees Celsius. Let me write that down. 1.86 degrees Celsius for every 1 molal of water, or 1 molal of water solution. Okay, again, this is only for water. That number can change. Okay, so the freezing point will go down its depression with every 1 molal. For water, the freezing point will go down by 1.86 for every 1 molal. This is called the freezing point depression, freezing point constant, or the symbol is Kf. Different liquids have different KFs. The formula is the same, but instead of B down here in the subscript, it's now F. Okay, try the next problem, please. Okay, so delta T is equal to KF Mi equals sugar. So it is, I'm sorry, it's freezing point, right? So the freezing point constant is 1.86, almost 2 degrees. 1.86 degrees C every molal. You have 2 molals. And it's sugar, so it gets 1 piece. Okay, so you multiply those, you're going to get 3.7 degrees Celsius. So if they ask you, what is the freezing point? This is not the freezing point. This is the freezing point depression. The freezing point depression is 3.7 degrees C. If they ask for the new freezing point, well, it used to be 0. It went down by 3.7 degrees Celsius. So the new freezing point is negative 3.7 degrees Celsius. So as you notice, the freezing point depression is always positive. Okay, it's the change because this is positive, this is positive, this is positive, so this will always be positive. But the new freezing point will be negative because it gets lower than 0 degrees Celsius. Okay, I want go ahead and pause the video and try the next problem. Okay, so it says I want my water to freeze at negative 5 degrees Celsius. So your freezing point is not your freezing point depression is not negative 5, it's 5. That goes there. Instead of 0 degrees Celsius, what molality? So I'm going to use the same constant, 1.86 degrees C over M. What molality? So this will be X of CaCl2. So CaCl2, you get C8 plus 2, that's 1 piece. Cl minus 1, that's 1 piece. Cl minus 1, that's 1 piece. So you get 3 pieces. Okay. What molality should I use? To solve for X here, you're going to get 0.896. 0.896 molal. And then they're going to ask, if I'm freezing 1.65 kilograms of water, how many grams of salt should I add? How many grams of CaCl2 should I add? So the formula is molality is equal to moles over kilograms. Plug in your numbers. This is 0.896. Moles is X, because I want grams, right? So I can get moles and get grams. Kilograms is right here, 1.65. That's my formula. X will be, when you solve that, I got 1.48 moles of CaCl2. Change that to grams because they want grams. If they want moles, you stop here. 1 mole is 110.98 grams equals, final answer is 164 grams of CaCl2. Okay, so this is how you do the problems. If the solvent is not water, they will give you the constants and you can plug that in there. Okay, but it's the same way. You do everything the same way.